Hello students, in this lecture we'll study the behavior of the curve and behavior of the curve in the domain or in the subset of the domain. So the behavior curve means the curve is concave upwards or concave downwards. If the curve is concave upwards, we will say that the curve is convex downwards. If the curve is concave downwards, we'll say that concave is the curve is convex upwards. So we'll study only one of these. Other will be the vice versa. We'll study when the curve is concave upwards, the interval in which the curve is concave upwards. Curve function is concave upwards. Other will be concave upwards means we are studying convex downwards. So we'll study one, and then remaining will be the curve will be convex downward, and we'll study the point of inflection, uh, point of inflection also. So let's first understand what is concave upwards or convex downwards. Let y is equal to fx is any function. So any function fx means it is trigonometric, it can be exponential, rational, logarithmic, or whatever polynomial, whatever function it may be. In closed interval AB, subset of it will be always subset of the domain function. Domain function fx is uh, is let f y equal to fx. So in this interval, domain subset is curve shown. The curve shown in the figure. The curve. The graph of the function is continuous in closed interval. So that is the graph made without lifting the pencil from one point to initial point to the terminal point. And the graph is shown no graph is smooth, that is no sudden change in the value of x. Now this is a graph. Graph, suppose whatever function taken, suppose the y is equal to f is a taken function and a to b, this is a to b interval is going to subset the domain. So we have drawn the graph of this function. This graph is on the graph, this graph a to b, and this graph is b. Now we'll study in which interval it is concave upwards, it is initial interval it is concave downwards, where at what point it changes to concavity from downward to concavity upwards, or we'll say one thing, concave downwards to concave upwards, or what this imply? This is convex downwards to convex upwards. This is again concave downwards, or you can say convex upwards. So we'll study concave upwards only. White line is white lines, chronograph and white lines. White lines are tangents, electron tangents at B, at C, D, E, F. The white lines are tangents at the point B, B, C, D, E, F of the graph of the function fx in the uh, in the open interval. None of the tangents is parallel to y-axis. Now tangent is vertical. Y-axis, therefore, the slope of the tangent at a point is finite real numbers. At every point the tangent is none of the tangent parallel to y-axis, so at every point the tangent is parallel. To, tangent have finite value. Thus, fx possesses unique tangent at each x belongs to the point. Which imply this has no sharp turn, this graph has no sharp turn at any point. Means at each point the tangent exists, unit tangent exists at each point in this. It will be unit tangents at each point. Now, during the study of the graph, three possibilities will arise, which are mutually exclusive or independent. Three possibilities arise means one is concave upwards. What is the name of that? This is convex. Concave downwards. What is the other name of this? This is convex upwards. And third is the point of inflection. Three possibilities will arise. when we study the graph of the function in the open interval a to b, right? So we'll study one concave upwards and other will be vice versa. Reciprocal of that will be concave downwards. Or concave upward means we are studying convex downwards. We are studying concave downwards means we are studying convex upwards. Same. Now let's compare concave downwards, concave upwards, or and convex downwards. Right? That is concave upwards means convex downwards, or concave upwards downwards means convex upwards. So the portion of curve above the tangent on both sides of the point of contact of the tangent to the curve. Portion curve Portion of the curve above the tangent on both sides of the point of contact of the tangent to the curve. The curve CDE. Curve CDE. This curve. Tangent is this is tangent, and the both side tangent is the curve is lying up with the tangent. So this implies CDE. The curve CDE, and this is the curve CDE. CDE, this is tangent. The curve can hold water. Right? Number one, the curve is holding water. Number two, as x increases, the value of the f dash x increases or changes sign from negative to positive. What does it imply? As x increases from A to B, the slope tangent at each point, f dash will give the slope tangent each point. Slope, slope was negative earlier, negative to f dash change sign from negative to positive. Negative means if you draw a tangent at this point, slope will be just tangent angle made by the line will be positive axis. And if it will be tangent is this horizontal tangent, and this will be vertical tangent here, this will be tangent, and then this will be positive. So as we move, as x increases from as x increases, the value of f dash increases. One either increases or changes sign from negative to positive. Already, as x increases, the slope f dash x increases. As x increases, this increases, and second derivative is different. X increases, h increases. The curve bends upwards. Okay, the curve is concave upward, then curve will bend upward. From these observations, you can conclude, or we can say the curve bulges downwards. So at this point, curve is bends upwards or bulges downwards. Bends upward or bulges downwards. So we can say that this is curve is concave upwards or convex downwards. 5 conclusions. We can conclude from the graph is mentioned. Similarly, bulges downwards. Reciprocal, this will be concave downwards. Portion of the curve below the tangent on both sides of the point of contact to tangent to the curve. This is curve will make hat. This hat. This is the portion. Curve is making hat there. This is A C E A B C hat number. E D F E F G hat number. This is concave downwards. From here to here, from A to ABC, this is concave downward. Hat making hat downwards. This is concave downwards. From C D E, this is concave upwards. This can hold water. So concave upwards will hold water. Concave downwards will become more will form a hat. And the point at which it changes to concave downwards to concave upwards is called point of flexion. Point C and the point E are called point of flexion. If you draw tangents at the points, then this will at this point the graph will lie on both sides. On the one side it is concave downwards, on the other side it changes to concave upwards. If it's concave upwards, then please do concave downwards. These are the point of reflection. C and E are the point of reflection of this curve. So as x increases, the value of f dash decreases. As x increases, the value of f x decreases, 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 or changes sign from positive to negative. Decreases or changes. As x increases, the slope this decreases. X will be less than 0. If the curve is concave downward, the slope decreases, and second derivative at the points, the interval at which the second derivative is less than 0, the interval in which this second derivative is 0, this is called, in that interval the curve will be concave downwards. If this is greater than 0, concave upwards. So the derivative greater than 0, concave upwards. Reciprocal of this, concave downwards. Curve, in this case, curve bends upwards. In this case, curve, it will form a hat with the curve bends downward. The curve pulses downwards, means curve pulses upwards and concave downwards. This kind of distinction between how to distinguish between concave upwards or concave downward, or convex downward. This is convex upwards. Point of reflection. If two branches of the curve at the point of contact of tangent to the curve lies on both sides of the tangent, then that point of contact is called point of reflection. Point C and E are the point of reflection uh, on figure, or the point at which the curve changes from concave upwards to concave downward, or vice versa, convex downwards to convex upwards. It's called point of reflection. The point at which secondary is zero or does not exist are the possible points of reflection. Possible. So in order to find the point of reflection, put this find secondary, put that zero and find the points, or the points at which secondary exist are the possible points of reflection. And now method to find the interval concavity, convexity, concavity, convexity. So first step is find the y-square fx function, find the second derivative of this. Second step is find the interval in which this is greater than 0. And this is 0 means the curve is concave upwards. And the interval in which the second derivative is 0 means the curve is interval in which the curve is upward. Now in the remaining interval, the remaining if the find the interval concave in which this is greater than 0 means concave upwards, and the remaining will be concave downward. This is less than 0. You are not supposed to solve both. And the point method to find the point fraction. So again, you have to find the same second derivative for the whether you are discussing the concavity upward, concavity downward, or the point fraction. Find second derivative function by equal fx. Now find the point at which second derivative is 0 and does not exist. Suppose A, B, C, D are the points at which the possible point fraction for the curve. If x is equal to A, will be the point. X will be the point of reflection if f double dash x changes sign at A. In the left it will be positive, in the right will be negative, or if in the left it will be negative, the right will be positive. Right? Changes sign of positive negative, or negative to positive. Like left of A better. And second is, or third derivative exists and is not 0 at x is equal to A. Second derivative 0 the points or does not exist. Now put the third derivative exists and is not equal to 0 at x equal to A. If first and second fails, reflection, second is 0, third derivative exists and is not equal to 0. That point is called point reflection. If second and first and second fails to find the point reflection, then at x is equal to A, find the higher order derivatives. Find the higher third, fourth, fifth, and so on. If the higher order derivative is not equal to 0, when n is even. If the even order derivative are not equal to 0, then x is not a point reflection. and x is not a, if you not a derivative, second, fourth, sixth order not a derivative, x is not a, then x is not a point function. As you see, x is equal to a is not a, x is equal to a is not a point function. And if this is equal to 0, when n is even and n plus 1 n is even, and so, n plus 1 is derivative is not equal to 0, the curve has a point of inflection at x is equal to x is equal to a, x is equal to a, right? X is equal to, right? So this is the procedure how to find, how to solve the problem in the next lecture.